Welcome to the House That STEM Built, a regular series where we will explore the science, technology, engineering, and math that goes into the design and construction of this family home. This is the House That STEM Built.
In this episode, we will focus on the Grade 10 Geometry, Measurement, and Finance Specific Curricular Outcomes, M2. Demonstrate an understanding of the imperial system by describing the relationships of the units for length, area, volume, capacity, mass, and temperature. And M3. Solve problems using SI and imperial units that involve linear measurements using estimation and measurement strategies.
Estimation, measurement, and calculation are skills that are very important in the residential design and construction trades. Throughout the process of planning and building a house, workers such as architects, carpenters, masons, plumbers, electricians, and landscapers rely on making accurate measurements, calculations, and estimates to get the job done right.
Canada adopted the metric system as its official measurement system in the 1970s, with such units as meters, liters, and grams being used in many aspects of daily life. However, most measurements used in the design and construction of Canadian homes are in imperial systems, such as inches, feet, and yards.
The main reason for this is because the Canadian lumber industry is closely tied to that of the United States, one of the only countries in the world that still primarily uses the imperial system for most day-to-day measurements. Since American lumber manufacturers measure their wood in inches and feet, Canadian manufacturers have decided to do the same.
However, in most parts of the world, the metric system is used in the building and construction industry. So, what if this house was being built in Europe instead of Canada? The designers and construction workers would use this metric system in their measurements, calculations, and estimates.
Back at our building site in Canada, our construction team will work primarily in imperial units. So let's have a look at some of the common measurements they will use. The blueprints, or plans, for the construction of the house show dimensions in feet and inches.
Here we see that this section of the roof will be constructed with rafters that are 2 inches wide, 16 inches tall, and which will be placed 16 inches apart from each other on center. And here, for the railing on this upper deck, we can see that the carpenter will have to make sure the top of the railing is 3 feet and 6 inches above the deck floor. This is to make sure that children on the deck are kept safe from falling.
All of these building materials were manufactured using imperial dimensions. There are 2-inch by 4-inch studs, known simply as 2x4s, as well as 2-inch by 8-inch boards that carpenters call 2x8s. We also have sheets of plywood and oriented strand board, or OSB, that are 4 feet wide by 8 feet long.
If we look at the floor plans for the construction of the house, we can see the area in the ensuite bathroom where the shower will be located. On the plans, we see that the floor of the shower will be 42 inches wide and 84 inches long. Since there are 12 inches in a foot, you can divide 42 by 12 to determine that the shower floor will be 3.5 feet or 3 feet and 6 inches. Similarly, we can divide 84 by 12 to find the shower floor will be 7 feet long.
The ceramic tiles for the floor and walls of the shower are each 12 inches wide and 24 inches long, or in other words, 1 foot by 2 feet. When the tile installer planned out the pattern for the tiles on the floor and walls of the shower, the fact that the tiles had 1 foot by 2 foot dimensions made the job easier. Since the back wall of the shower is 7 feet wide, we can see that it takes 3.5 tiles to cover this distance. This is because 7 feet divided by 2 feet the width of each tile, equals 3.5 tiles.
Some rows start on the left side with a full tile, and other rows begin with a partial tile. But each row has a total of 3.5 2-foot wide tiles to cover the 7-foot distance.
Next, we have a look at how Finnish carpenters use very precise measurements to add the finishing touches to homes so that details like window and door trims look good. To make sure wooden trim pieces that will hide the gaps between the window frame and the wall material fit together perfectly, the carpenter measures to precise portions of an inch. In this case, the trim piece needs to be exactly 46 5/8 of an inch long.
The carpenter transfers the measurement to a piece of the trim board, being very careful to mark it with a pencil at exactly 46 5/8 of an inch. He then cuts the board, making sure the blade of the saw is in the right place to leave the board exactly the right length. This level of precision in measurement ensures that the finished product looks perfect.
The paving crew that completed the driveway for the house used specialized equipment to assist them with their measurements. This device provides a beam of laser light that can be detected by a receiver attached to a measuring stick.
When she's solid beep like that right there, she's right on the money. Okay.
The paving contractors need to make sure that the paved surface of the driveway is gradually sloped away from the house so that the water from the rain and melting snow flow towards the yard and not into the garage or basement. Using laser leveling and measurement tools guides them in the placement of the crushed rock to create the necessary drainage slope before the top layer of asphalt pavement is applied.
For water to flow properly and not create puddles on the driveway, the crushed rock needs to be sloped at a minimum of 2.5 inches of vertical drop for every 10 feet horizontal distance. This 2.5-inch drop, when divided by 10 feet, or 120 inches, can be converted to a percentage out of 100. You can see that it works out to be what is referred to as a 2.08% grade, which is just slightly steeper than the minimum 2% requirement for proper drainage. Once the asphalt pavement is applied on top of the crushed rock and it is compacted with this machine, the paving crew tests out the driveway's ability to properly drain water away from the house and garage. For this driveway, the paving crews slope the pavement at a close to a 3% grade so the water easily makes its way off the side where it will drain into the ground. Knowing how to make these important measurements and calculations makes the difference between a driveway that dries quickly and safely after a rainstorm and one that stays wet and slippery.
In this episode of The House That STEM Built, we saw examples of how home builders use their measurements, calculations, and estimation skills every day. Although measurements of most of the common items like food, gasoline, speeds, and distances traveled are done using the metric system in Canada, the home construction industry relies on the imperial system of measurement. This includes units such as inches, feet, yards, and pounds. Besides the examples shown in this episode, what are some of the examples you can think of where the imperial system is used for measurement?